Hi friends, today let's discuss chapter 5 lesson 4 medians and altitudes. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. If the three medians of a triangle are congruent, the point of congruency is called the centroid of a triangle. The centroid is always inside the triangle. So look at this. So the medians of a triangle have a special congruency property. Look at this here. This is in the case of the acute triangle, and this will be the case of the right triangle, and this is the case of obtuse triangle. Now let's check the first theorem of this lesson, congruency of medians of a triangle. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. See, look at the figure. If B is the centroid of a triangle ABC, then AP should be 2/3 of the AD. Same way, BP, look at that, and CP also 2/3 of CE. The centroid of a triangle can be used as its balancing point. Look at this figure. A triangular model of uniform thickness and this density will balance at the centroid of a triangle. So let's check one example. P is the centroid of triangle QR as shown below, and PT is equal 5. Find RT and RP. So we know P is the centroid, so RP equal to 2/3 of RT, right? So we can write like this one. So your answer, you can find RP equal 10. If RP equal 10, we know RT should be equal to 50. Let's check the next example. Find the coordinates of the centroid of triangle JKL. They already provided the coordinates. J is 7, 10, K is 5, 2, L is 3, 6. So the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So we are choosing the median Kn. So we can find the coordinates of N. The midpoint of JL equal, well, look at that. So we know the midpoint formula. By using the midpoint formula, we'll get the coordinates of N are 5 and 8. X coordinate will be 5 and Y will be 8. Now let's find the distance from vertex K to the midpoint N. The distance from K 5, 2 to 5, 8 is actually 8 minus 2 or 6 units. So determine the coordinates of the centroid, which is 2/3 of 6 or 4 units from vertex K along the median K. So the coordinates of the centroid P are 5, 2 plus 4. We know 5, 6. Now, how you'll use the altitude of a triangle. An altitude of a triangle is a perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. An altitude can lie inside, on, or outside the triangle. Every triangle has 3 altitudes. The lines containing the altitudes are congruent and intersect at the point called the autocenter of the triangle. Now let's check where is the autocenter of an acute triangle. Let's draw an example. So the 3 altitudes intersect at G. The altitude from C, this altitude, and this altitude will intersect at G. So the 3 altitudes intersect at G, a point inside. Well, where is the autocenter of a right triangle? The 2 legs, segment LM and segment KM, are also altitudes. They intersect at the triangle's right angle. So this implies that the autocenter is on the triangle at M, the vertex of the right angle of the triangle. So where is the autocenter of an obtuse triangle? So 3 lines that contains the altitudes intersect at W, so a point outside the triangle. Look at this figure. Alright, let's check the next theorem. Congruency of altitudes of a triangle. It states that the lines containing the altitudes of a triangle are congruent. Look at this. Here segment A and segment BF and segment CD are altitudes of triangle ABC. Well, then the lines AE, BF and CD intersect at some point H. Use the given diagram shown the given information to decide in each case whether segment AD is a perpendicular bisector or an angle bisector or a median on an altitude of triangle ABC. Let's check first if segment DB congruent to segment DC. It's a median, so we can say it is median. If angle BAD congruent to angle CAD, we can say segment AD is angle bisector. If DB congruent to segment DC and segment AD perpendicular to segment BC, we can say it's perpendicular bisector. If segment AD perpendicular to BC is an altitude. If triangle BAD congruent to triangle CAD, we can say these all will satisfy. Use the figure shown and the given information. Here L is the centroid of triangle MNO, and NP equal 11 unit, ML equal 10, and NL equal to 8. So find the length of segment PO. So of course we can say PO should be equal to 11. We know if L is the centroid, this is the midpoint, right? P is the midpoint of NO, so PO also will be 11. And find the length of segment MP. It will be 2/3 of MP. ML is actually 2/3 of MP, right? Is already provided 10. So we can say MP equal 50. And find the length of segment LQ. Here, NQ should be equal NL plus LQ. And NL is already provided 8. So first we are finding NL. This is 2/3 of NQ, right? So we'll get NQ equal 12. If NQ is equal to 12, you know what will be the measurement of LQ. It will be 4.